Can everybody in the back hear me? Cool. I'm a loud person. So I'm here to talk about two different types of code. One you probably all know about, and the other one you probably don't think about, but controls everything around you. So computer code and government code. So Paul Ford had this kind of famous article, What is Code? A lot of you probably read it. And there was one very specific answer, which is the left side of this slide, which is computer code. Thank you, Laura, for having a little explanation of what some programming languages be. But I have another code that I deal with every day that I think is really important for you to think about, which is the law. Is also called code. It's a codified rule of ethics. That's a screenshot from the Los Angeles Municipal Code. I actually have a couple binders full of it on my desk. And if you go to the LA City Archives, I was trying to find a photo today of the old archived 18th codes dating back to the 1700s. Fun fact, City of Los Angeles is older than the United States of America. But before I dive into the differences between computer code and government code and how we can make them all play nicer together, I want to give you a little sense about what I do. So by day, I'm the senior data scientist for the City of Los Angeles. I lead our small but mighty data science team. You'll hear a little bit more about what we've been doing, trying to make your lives better. By night, I co-founded a lobbying organization called the Policy Club. We go to Sacramento to lobby for legislative changes that are actually going to be effective at helping your lives rather than necessarily being like, oh, we passed this policy, but we don't really know if it works because we didn't measure it because it turns out we didn't have the government code talk to the computer code. So I find this to be a pretty motivating thing in my life. Before that, I was at the Data Science for Social Good Fellowship, Hack Night and Hack for LA, so I'm very grounded in civic technologies thing. Hack for LA, all volunteer organization, meetups on Tuesday and Wednesday. Please show up. We want your help. So please feel free. And you can find me on Twitter pretty much constantly. There's my handle. So a little bit about this place we all live called Los Angeles, this little adventure of a little city in the desert. We've got about 4 million residents in the city of LA. We have the largest street network of any city in the country to maintain. It's about 6,500 lane miles. We service about 700,000 service requests a year. How many of you have filed a service request with the city of Los Angeles via the 3-in-1 system? Good. I love you all because your data shows up in my dashboards. You should all be doing that. Did you know the city will pick up any bulky item from your curb for free within 24 hours? Your tax dollars at work, ladies and gentlemen. We're very happy. We have 46 departments. I'd like to joke we're an A to Z city, everything from the airport to the zoo. So what does it mean to do data science for a city government? When you work for a company, any sort of data project generally ties down to this question of how does this company make money? It's a little blunt. There's all sorts of things. You can be growing the company. You can be trying to optimize a process. There's a lot of different ways to solve it. But at the end of the day, the reason a company exists is to make money. What does that mean when you're in a government? So what it means to work in local government, and this is why I think local government is very different than my colleagues at the federal level, is we're on the street every day. Most of the staff of the City of Los Angeles are in the uniformed services. What are the uniformed services? That's your LAPD, LAFD, and sanitation departments. We pick up the garbage. We plow, the joke is, we pick up the blank garbage and plow the blank streets, is a joke from Eastern machine politics. But our job is to serve the people, be there for you. So people think, because I work for the government, I have access to this massive database of resident information where I can query oh, your car was at First and Alameda and we need to track it and somehow I'm stopping crime and talking to cops all the time and doing this insane hackersy, the Italian Job was filmed, controlling the traffic signals all the time. We do control the traffic signals all the time. No, we cannot make it the red lights turn to green when your car shows up. I'm sorry. But there isn't this massive system. Instead, government is all about the art of this. These are all legitimate emails from my inbox of me sending a follow-up email. I know in my first 6 months on the city, I sent a grand total of 325 emails with the words following and up in them. And this speaks to what being involved in government, being involved in civic life is all about. It's all about showing up. It's all about following up. So wanted to talk about a few projects we've been able to do at the city that I think are really cool applications of data science, and how our little 5-person team makes a city of 4 people's lives better in a city of 4 million residents. Who among you have heard of the Ellis Act? All right, who among you lives in a multifamily apartment in the state of California? AKA you have an apartment you rent from, there's more than one home in there. All right, so due to a 70s era law passed by the state of California, your landlord can immediately evict you and break all the leases if they choose to convert the condominium to, if they choose to convert your multifamily building to condominiums and are in compliance with a number of different regulations. And I can go into this very long government code definition of this, but you will all be asleep by the time I finish reading it. So essentially, what it allows landlords to do is break the leases. However, there's a lot of terms and conditions that apply, as is often true with government laws. And what we find landlords tend to do is they try to convince their residents that they're Ellis Acting a building, but they don't want to pay the fee to local governments. Typically, these are buildings that lower income tenants, over 50 languages are spoken in the city of Los Angeles. Often the people who are leasing it might not speak English. So they'll go and say, we're Ellising your building, you have to move out. But they won't tell us. And they won't file an Ellis Act request. We actually have inspectors who are out there. Their job is to catch these sort of Ellis Acts in progress. But the problem is there's well north of 500,000 multifamily buildings in the city of Los Angeles. So how do you decide where to send our team of 20 inspectors in a city of 500,000 people? So we built a model for predicting where Ellis Act removals were likely to occur. This gives us a targeted list of multifamily buildings. So this is a map that our team uses to figure out where they need to be doing outreach and education among tenants so that they know that they have a friend in city government and a number to call where they can speak. I think we have staff that speaks like 7 different languages fluently in this one division. They speak an insane number of languages. They're lovely, lovely people. And this has allowed them, we've had them go out 3 or 4 days before an Ellis Act was filed where these people did not even know this was a law, did not know anybody who worked in city government, and was able to get in touch and help prevent an eviction that was going to happen where they wouldn't have been paid the appropriate compensation for an Ellis Act, all these sort of things about requiring you to follow the law. Another project we're working on is earthquake early warning, along with our partners at Cal OES and the United States Geological Survey. So who among you was around for the Northridge quake? Am I dating myself here? I might be. Yeah. Who around you? So one of the things is we want to give you about 30 seconds to 2 minutes of warning when an earthquake might occur. By predicting the P wave and S wave, turns out the speed of sound of seismic waves through rock is only about 100-something miles an hour. That gives us enough time to pick it up on this network. We put basically a pickup truck size sensor all up and down the Pacific coast. The network is now operational for the LA area, which is really exciting. So I would say by Q1 of next year, we're going to be shipping an application that Angelenos can use to give you 30 seconds to 2 minutes of warning about an earthquake, so that's enough time to evacuate a building. There's some amazing videos. They actually have the system up and running in Mexico City. You can Google some amazing videos of buildings being entirely evacuated before the shaking starts. LA Metro is currently using this system. Your train will stop before an earthquake happens. There's applications about this in the Port of LA, automatically shutting off our fuel lines so that it turns out if we have an earthquake happen and all the fuel lines are open on the port, we might set a fire in the port. And my personal favorite application that we're enabling is this, which is we are going to automatically raise the fire engine station doors. And you're asking me, Hunter, why is it important that we raise the fire engine station doors with this? And the answer is, it turns out during the Northridge quake, about 50% of our fire trucks did not leave the station for an hour after the quake because the quake had shaken the door off the rails to move it up. So they had to manually break through the doors and lift it up. It took them about an hour in the middle of the biggest earthquake since, I think, 1950. Landers quake was 19. Anyways, a large earthquake. So if we can have a system automatically raise the doors, we can get our first responders out before a disaster strikes. And then finally, we are using machine vision to automatically count pedestrians and cyclists. Little known fact, we have this incredibly complex network of roadway sensors embedded across the streets of Los Angeles. If you've ever looked in the road and seen like this little circular thing in the asphalt, it looks like a black circle in each lane. These are called RITS sensors, which stands for Regionally Integrated Transportation Sensing Network. And it tells us basically how many cars are moving through any roadway, what's their average speed. We have this really detailed data that we use to time your signals, make traffic flow smoothly. Really kind of crazy project. But one of the things is we don't treat pedestrians and cyclists, our most vulnerable road users, in the same way. So we want to measure the effectiveness of a bike or pedestrian safety project. We string up a camera or we send somebody out to a curb for 24 hours before we do a project. They have a big tally sheet and they go 1, 2, 3, so on and so forth. So we've been working with a network of about 500 cameras we use for traffic monitoring citywide that we typically use to measure the situation on the left of the roadway with cars and trucks to help us measure pedestrians and cyclists at scale using machine vision. So this is a really interesting project that allows us to finally really attack the huge problems. This is our Vision Zero high injury network. These are the most dangerous streets in LA. More people die in LA because of car crashes and basically roadway accidents than die in gang violence every year. So making sure our roads are safe is one of the top priorities for the city. And if we can't count who's using our roadways, we can't make that happen. So code at the City of Los Angeles, that's a very small subset. There's about 50,000 employees of the City of Los Angeles. About 2,000 or 3,000 of them code every day. So it's a pretty big thing. We have GitHub. We have about 35, 40 open source repos growing every day. All of our geographic data is posted for public view at geohub.lacity.org. We have a whole bunch of other data at data.lacity.org. You can see what my team does at dsf.lacity.org. Typically for data science, we were an open source stack, Python, Jupyter Notebook, R. Our web services team uses JavaScript, Drupal.net. We have this MyLA 311 application, and we do all sorts of crazy things like mainframes and helicopters and embedded systems across every police car. It can get really kind of crazy when you talk about technology that has had to exist. The government does not go away. So all of our technology needs to exist and serve every resident of the city of LA. So it's a really interesting place to be doing programming. Cough, we're hiring, so please consider applying and coming and joining us in the public sector. You can just Google like LA City, LA County jobs. They're also hiring. They're also great. I guess everybody's plugging some other meetups. So my other plug meetup is Data and Donuts. We do once a month talks about data and government if you want to get in depth. I know some of you here in the audience have been there. Good experience? Good experience. All right, we got a letter of endorsement. I like that. So please consider, it is at 8 o'clock on a Thursday morning. So I know this night might not be the crowd to be selling that, but get up early. I bring plenty of coffee. The donuts are free. Come talk with your fellow government employees and your public servants. Thanks so much. Yeah.
I was wondering, do you make use of semantic web technologies to expose data?
Honestly, not my team, but it is entirely possible that somebody else does. Government is huge. So there are more government employees working in the Civic Center of Los Angeles than anywhere else in the country, except for Washington, D.C. Little known fact. Yeah.
So a lot of the technology that you use to create these platforms or to provide the services you just spoke about, do you code in-house, or are there instances where you hire outside companies to help provide?
I would say it's actually more typical that we do hire outside. We're large. LA City is large, so we have more in-house resources than, say, the city of Pasadena or the city of Gardena. But typically, let's see if I can pull this up. But let's go see labavin.org. So we buy all sorts of crazy things. Let's see how much. Let's see what we're buying. Yeah, see. Tons of different various contracts that we've put out. You can see. So this is BRT communications upgrade machine. So we bought This is a contract that we issued a couple years ago that's pending award right now to upgrade the communications networks along Wilshire Boulevard so that the rapid buses are automatically switching the signals across there. So there's a company that is making those embedded sensors that are going to go on the signals. There's also a different company that's going to make the ones that go on buses because that's a different government agency and life has to be complicated sometimes. So yeah, typically most of the stuff like that earthquake early warning application is being developed by a vendor. We just developed what is called an RFP, request for proposals. This is where you can go browse all of our RFPs. You can see, I think here if I search earthquake early warning, you'll see the one I wrote. But yes, governments buy, okay, maybe it's not showing up, but we buy a ton of software.
So, but you have a team of in-house programmers. Typically, what kind of projects do you work on?
So it ranges, as I said, it's an A to Z. So typically we're handling smaller stuff or really scoping. Actually, as a programmer, you spend a lot more time of your time thinking like, what is the architecture of the system we're going to build? And then we're going to bring it out to the vendor who actually gets to build it. So that's sort of how we do it, and obviously depends on what budget's assigned. We can talk about the whole process of making the law and making the budget and how this all interrelates. But one of the things that like kind of didn't come together in this talk as well as I was hoping to, but there's not really a good tie-in between like good computer code practices and good law practices. And like, you know, I'm a historian by training, so I like fell into programming as well. And what is interesting to me is this like law and social contract doesn't necessarily deal with those like harsh realities of like name fields, like all those horrible sanitized name inputs. I'm like, oh, I know which laws like about your social security, like the Social Security Act of the 70s has like a specific mainframe database that doesn't allow special characters. That's why we can't put anybody's special characters into your social security card. The DMV systems are also antiquated, and there's like this over budget project, not to pick on CA DMV, but like their vendor has kind of like completely imploded on like overhauling the DMV system. That's why we have to like we have these ancient systems because like we can't just say, you know, okay, we're restarting Social Security. There's, you know, 200 million Americans who depend on Social Security who are in the system already, 300 million Americans. So that's one of the complexities of working in government is like there's a reason why all of these things happened, and we need to do better because our residents deserve better. Yeah.
What is the best website or app to look at metro times buses?
Use Dash because we have a better vendor. So there isn't actually a best app. I like the Dash because we spent more time on this. But so actually all of those feeds are going to be identical across all the different apps because they're all subscribing to something called a GTFS feed, aka a General Transit Feed Specification feed. So go to Metro Developer. Let's see. Yes, there's a developer portal for LA Metro. There's also a developer portal for LA City. But you can go get in real time. Let's see how quickly I can do this. Download Metro. So here is
Based on the GPS on buses.
yeah. So so this is in real time. This GitLab repo is updated, but we have real time. You can read all this stuff in this README. Like it's open source. Here's Metro on GitLab. But like all of those, all these apps are not making separate predictions. All of them are just ingesting the government's prediction in an open format called GTFS. And that's why you can go on Google Maps and like it doesn't care if you're trying to go on Santa Monica Big Blue Bus or Metro or LA Dash or any number of the other 26 different transit agencies in LA County, because we all agreed to publish in this common format. So it's actually all one system. Yeah. That's a way longer answer than.
Time
Yeah.
for one more question. I'm sure you get this asked all the time. So let's say you're at a red light, right?
Yeah.
If you go backwards and then forwards, backwards and forwards, will the light change green faster?
So a very, very large it depends on the time of day, the signal timing, what the ATSAC engineers are doing. We have something called ATSAC, which we actually developed for the 1984 Olympics. So this is this crazy system like that you can control like in the basement of my office, we can go control every single signal in the city of Los Angeles. And all of this was built pre the internet, or mostly pre the internet. So like, whoever tells you government can't be innovative is like lying to you. We just have to care enough to solve that problem. which is like traffic during the Olympics, was apparently a big enough issue to solve. So broadly, it can potentially trip a signal retiming thing, but typically no. We try to keep signal timings mostly consistent for reasons of like optimizing control flow, and like a traffic engineer can give an even longer answer than this, but this is like me trying to summarize an entire field of study in about 3 sentences. Thanks. Awesome. Thank you all.